Yeah, fantastic. So we're really lucky to have Alexander Zadovsky here from FreeCAD. So he's going to speak a bit for a little while, and then you're going to do a workshop next door for those that want to learn more, do a deep dive. Yeah.
Directly after this.
Perfect. So if FreeCAD's something you're interested in or learning more about, you're in the right place. So without further ado, Alexander, come up and take the stage, and we'll get you all set up. Go ahead and roll the intro.
Welcome everyone to my talk today about the revolution that is taking place right now in mechanical engineering through open source software. Why this is important is because thanks to open source software, mechanical engineering startups can now implement new business models, and this whole movement is changing how mechanical engineering works. So, my talk is going to be a little bit more in-depth. I have heard some of the other talks, they were more macro perspective. This is more micro perspective. So what are all the benefits of using open source software as a machine manufacturer? First, you are not forced to any costs like with all the proprietary CAD software. Second one is you have the freedom. You are not limited by any licenses. You can do still within the open source license whatever you want, but you have much more freedom in what you do with your software. Third benefit of using open source software as a manufacturer is you get much more training material than for all the proprietary software, because in this case, we will be talking more in depth about FreeCAD, but right now this applies to all open source software. You have got big communities online which create training materials, videos, written tutorials, a lot of learning resources. And also you get the extensibility of your open source software, which allows you to extend it so that it supports your business process. And all in all, this creates new opportunities for machine manufacturers, machine manufacturing startups, and this is what we will be talking about today. So, who am I to talk about this? I'm a still student of mechanical engineering at Hochschule Bonn-Rhein-Sieg. I have been a long-term member of the FreeCAD community. And after some time, I founded the world's first FreeCAD support company, where our goal is to provide this safe space for companies to come to, because I think this is one of the most important points of how we can integrate FreeCAD more and more into the industry. Big companies, they need reliable access points for support and for development, and this is what we are trying to do with this. I've also written a book on FreeCAD, which is called FreeCAD Beginner's Handbook. I've worked as an employee also at a big machine manufacturer. I have invented and patented a screw, and currently I am working with the company Altair on open source software for automotive crash simulations. And my mission is to bring open source software to manufacturers, and especially make FreeCAD the standard by 2069, which is the year I'm going to die according to the German government. This is true. So throughout the development process, when you're building a machine, you need to create a lot of files, documents, and I have tried to capture the most important of all of them, but there's obviously much more. But the goal is here to show that the whole process can be done using just open source software. As you can see, most of the work is actually not in CAD. Most of the work is in spreadsheets, writing documents, and creating presentations. And yeah, FreeCAD work is maybe 5 to 10% of all the work. But you can implement the whole process using open source software. I've already done this myself. I've demonstrated this before. And today we will focus more on FreeCAD. But I just wanted to show you that it's possible to represent the whole process in open source software. So what is FreeCAD? FreeCAD is an open source CAD software where you can you can design your machine, and because FreeCAD has a universal interface, it interfaces very well with other CAD software. So thanks to that, you are not limited to now I can just work with this software. You can still use other software in combination with FreeCAD. And in FreeCAD is built up very modularly. It has different modules for different applications. And the most important ones are Part Design, A2+, TechDraw, and FEM, which you can, with just these workbenches, you can do pretty much 90% of your work in machine development with FreeCAD. But then you also have the Python API where you can add your custom functionality. And as already said before, FreeCAD offers a big community consisting of a wiki, of a forum, and multiple social media channels. So yeah, let's take a broad look at FreeCAD, what goes in, what goes out. Most of the time you will be working with step files, so you import step files that you created or someone else created in another CAD system, and what you export is usually also either step files, but sometimes also DXF, SVGs. These are different file formats that are necessary for manufacturing. And because of these interfaces, FreeCAD can be integrated into every product development process. First thing is creating all the individual parts in FreeCAD. And you do that in the part design workbench, which follows the sketch-based solid modeling workflow. You usually create one part per document, even though it's technically possible to create multiple parts per document. But for the assembly later on, it's better to create one part per document. And these could be components for milling, turning, injection molding, and any other process. Here I've shown a construction set brick, which is a competitor to Stampfi. Everyone, I think, knows what this is. Yeah, and when you design these parts, you can just directly design them in FreeCAD, or you can link them to spreadsheets that are also integrated in FreeCAD and make it even more parametric than it already is. And yeah, the parts that you create here, they can all be exported in different file formats. For example, STEP, which is very important for the classical manufacturing methods, but also as FreeMF and STL for 3D printing. When you have created all your individual parts, you then create your assembly in CAD, and you can do that in the A2+ workbench. FreeCAD already has a newer workbench, but it's really new, and I have used this workbench for many, many years. And before I introduce a new workbench to myself and to the people I work with, I first have to really validate it. So it's too new right now to introduce the new workbench. But you can import parts created in different CAD software from part suppliers. Usually they provide these files on the internet. You can you usually import those also as step files. You assemble those through constraints between topological elements like points, lines, and faces. And this process works quite well for small to medium-sized assemblies. For larger assemblies, it's usually better to use other methods, but I think those do not apply to the people here at this talk. Yeah, and you can also export the entire assemblies as step files and later on import them in another CAD software. So you're never bound to FreeCAD. By the way, this is an EV platform that we have developed together with Altair, which we will use to teach mechanical engineering students how to do crash simulations using just open source software, which is for the first time ever possible because we have created a link between two other software, but that's not part of this talk. Yeah. So when you have created all the individual parts and your assemblies, you usually need to create the technical drawings. Yeah, you derive these technical drawings directly from the 3D parts as opposed to creating the drawing from scratch like you have to do in LibreOffice CAD or whatever it's called. Yeah, you can automatically generate the views. You can create section views, detail views, create annotations, surface roughness, tolerances, all the important stuff that an engineer needs. And we need the document because it has a liability. You need to create this document to clearly communicate to either the people at your company who manufacture this or to other companies who manufacture your product, because this will be the document that you will be held accountable for. Yeah, and it's also possible in FreeCAD to create.
Ask a question. What the digital format? Oh, sorry. So it's not the digital format, but the paper format, which is the accountability.
The pages are first internal in FreeCAD, and you can export them as PDF or SVG. Does that answer your question?
Where I come from, the digital format is the liability format. You have to, if you produce a part, it has to comply with the digital format, because usually it's printing or you don't print this, you print the digital format into a slice and then go on. You see what I mean? So the digital format is the basis, and this is a visual representation. People can read, but if this is different than what is in the digital format, you will have a different product.
What do you mean by digital format? This is digital.
It means the 3D file.
Oh,
So, but this is derived from the
yeah.
3D file is generated.
Yeah.
So it's just a projection of it.
Yeah.
So it's identical dimensionally.
So
It's just so you can put it in front of someone and say this measurement is this, rather than having to show them a multi-dimensional thing, then use a ruler tool or whatever.
if I give this drawing to a person with a metal workshop and I ask him, please fix this, then the drawing is the only document with the information to make that product.
Yes.
Then you're right. Then this is the liability document. But CNC milling, for instance, is done with the underlying digital format. So
Yeah, but you still have to provide this. You cannot just send them the step file because it does not contain the tolerances in usual cases. You need the tolerances, otherwise it's not complete.
so it's both.
You need to send both, usually.
Okay, got it.
Yeah. So, and then after you have designed your parts, and after you have done your preliminary design with formulas and estimates in some spreadsheet, you can also do the FEM analysis, where you can simulate, for example, the stresses, heat, and other stuff like that. In this case, we simulated an end plate for a hydrogen fuel cell from a project from Fraunhofer. And yeah, you do this to validate your theoretical calculations that you've done before, which we have not looked into here. Yeah, setting up the simulation can be done directly in FreeCAD, and doing the simulation, everything, the solver, the pre-processing, post-processing, everything can be done in FreeCAD. This also works like any other FEM software. You have to define boundary conditions, material, mesh, solver, and you get your results at the end. Yeah. So, and this is important to make sure that your product is safe, first of all, because also the liabilities, in this case, this is not super critical for this part, but there are some parts where it's super critical, and you need to make sure that your part withstands all the forces. Yeah. So here's an overview of how this workflow works applied to a 3D printed work holding fixture. So you first start out with your fixture concept. You have already done all your preliminary design, all your calculations. You create your CAD component and in part design, and then you create your assembly from all the individual parts. You can explode the assembly and then derive the assembly drawing, or directly derive the assembly drawing, and you export it as a PDF and send that to the manufacturer or to your own people. Yeah, and as you do the FEM simulation based on the individual CAD components. Right now, it's not so easy to do a simulation with an assembly in FreeCAD, but it's usually better to just do the simulation on the individual parts. And yeah, you get all your outputs that you need. You also use the CAD assembly to check for collisions. So, and you can create screenshots within FreeCAD and export those and create annotations. This is an often overlooked feature, because when you're communicating with other companies, you usually have to create some image, draw a circle, annotate it somehow. It's far easier to communicate that way than to screen sharing every time in setting up meetings. Yeah, and all of this can be done with FreeCAD. And yeah, when you go to the edge of what's possible with FreeCAD, you may want to create your own tools, and that is possible in FreeCAD. There are also frameworks provided by developers from FreeCAD that already give you some guidelines as to how you should structure your add-ons for FreeCAD, so that they are also easily integrated into the add-on manager. So any person developing an add-on for FreeCAD can get it into the add-on manager first, and then all the people can download your add-on in FreeCAD. You can code all of this stuff up in FreeCAD itself, but I prefer to do this in VS Code, because for bigger projects that is much easier. You can also use the integrated terminal in FreeCAD, where you can interactively create code, and you can immediately see what the output of it is. So you can go through the hierarchy of your document objects and just explore it, learn about how FreeCAD works. And there are also helping features in FreeCAD which help you understand how FreeCAD is structured. Yeah, and because of this functionality, FreeCAD is the only CAD software that offers these very niche applications, because for bigger companies these wouldn't make financial sense to develop them. But yeah, because of FreeCAD, because someone developed something for themselves and then later on shared them, we get these like very, very niche applications for features in CAD software. And yeah, FreeCAD has a big community. It has got a wiki on the left, and it has got a forum on the right where all the developers are, and you can talk to them directly, ask questions, and and also share your projects there. There is a specific forum for that called Users Showcase, where you can share all your projects, and people really like that. Yeah, and after you have created your files for FreeCAD, you can then organize all the product data from your machine in a spreadsheet with LibreOffice Calc, and this is how it could look like. This is basically just a list of all your different parts and products, and it also links to the CAD files, it links to the risk assessment files, it links to the technical drawing and everything. You can collect all your product data in one place. There are special softwares for this. This is also called PDM, and as a bigger evolution of that is PLM, but you can do a lot of stuff with just spreadsheets. So this is low-tech, everyone can do this, and this is important when you are a machine manufacturer because you need to share data across team members. To make this all even more production ready, you can combine this with SVN, which is consisting of a server or a centralized server in your company, and install the SVN clients on your team member computers, and this way you keep all the data in a central place, and all the team members can access the data, because in Subversion you can assign different roles to different people. You can you have this is like Git, but it's better suitable for mechanical engineering, I think, at least. You avoid file collisions because you can block people from modifying a file. Yeah, I think this is a better system for mechanical engineering than Git, but yeah, maybe at some point Git will become more suitable. You can also combine this with a RAID on your system and a UPC to keep the PC running when you have an energy outage, and you should also make additional copies from all your data in some other physical location. This is all important because of the liability of building machines. Most software engineers don't care that much about their stuff, but when you're building machines, you usually need to keep your data for like 10 years at least, or otherwise you are in jail with 1 foot. So, yeah. And we have started developing a PLM solution some time ago, which combines the previous steps, which would be this spreadsheet combined with this and other additional features, just to make it easier for people to set this up, and usually mostly for input validation and making it more seamless, but you don't need this. So here's how the downloads have developed for all the versions of FreeCAD. And as you can see, we are on an upward trend. The version 18 has much more downloads than the one after that, because it was the one that was there for the longest time. So these are not all yearly releases, but I think 18 was 2 or 3 years, and the ones after that just 1 year. So you have to account for that. But if you account for that, you can see an upward trend, and 1.0 has just been released some time ago, so we should give it some time. But as you can see, it pretty much grows exponentially, and we have nearly 20 million downloads as of today. Here's just one example project of what can be done with FreeCAD. This is a pharmaceutical tablet press made in open source software. We do with a university where the students do this as part of their curriculum. Then we have this EV platform, also completely done in open source software with Altair, and this is a crash simulation based on the Euro NCAP standard that we have recreated. And here another one from aerospace. This is the Mars rover drop-off simulation, also completely done in open source software. And all of these used FreeCAD. Yeah, as already announced, we will be doing a workshop where we'll show how a Mars rover can be built in FreeCAD, first doing all the individual parts, then assembling it, and then exporting it for 3D printing. So if you're interested, just stay with us. Yeah, this is what we are offering with our company. We have to survive somehow and keep this mission moving forward. And you are not really the target group, but I thought I would still keep this in here. So we offer training, integration, and development, and it usually also goes this way. So first companies want to be just trained, then they see, oh, we need to integrate this into our other software and validate that all the interfaces work, and then we do some custom add-on development. And you can get FreeCAD today and do everything that we have just shown you before today, like I will be showing you later. Yeah, so my mission is to bring open source software to manufacturers and make FreeCAD the standard by 2069, and we have accomplished really a lot this year. So we met up with VDI, which is the German Association of Engineers. This is a big deal. We also work with Altair. We have, we are officially the Deutsche Raumfahrtakteur from DLR. And yeah, right now there is a lot of stuff happening. I will not go into detail into all of these things, but yeah, this year has been very stressful. But thank you very much for hearing me out, and I hope you like this talk.
Fantastic. Round of applause. We've got a couple minutes left. You want to take a question? And then if you have more questions, by the way, Alexander's just going to move next door, and you're more than welcome to do more intimate conversation over there as well. So, but a question here real quick.
So, hi, I do, both Cura and Orca Slicer are open source softwares used for 3D slicing. And I took a quick peek at your FreeCAD GitHub, and I saw that in the last 24 hours you had 12 different PRs committed to your repository. How do you balance keeping the community happy and making sure that whatever is contributed is in line with the roadmap and how you stay alive?
So, yeah, I'm not really responsible for that because I'm the person that is bringing FreeCAD into the industry. But keeping the FreeCAD project development running, that's where the FreeCAD Project Association is responsible with Jorik and Jürgen Meyer and other people. So, yeah, I don't know. They do this stuff. I just focus on the industry because I have more experience in that, and I don't focus that much on the core development of FreeCAD.
That's a really great question, though, and one that I think a lot of open source projects could do better to probably address. So thank you for that. Again, round of applause for Alexander here. Please feel free to join him next door if you would like. Thank you so much.
Watch our project zoom.